Alright, the next stop in our journey of dealing with these rational expressions is going to be adding and subtracting. We just finished doing the simplifying, multiplying, and dividing, and now we're going to be adding. Now, adding or subtracting rational expressions is just like adding or subtracting normal fractions. You need to make sure you have a common denominator. So, for the first part, we're going to look at ones where they just have the same denominator already. So to add or subtract rational expressions with like denominators, we're going to simply add or subtract their numerators, then place the result over that common denominator. So that denominator does not change. So for example, if we have 3x over 5x squared plus 7 over 5x squared, the denominators are the same. So we add the numerators 3x plus 7 over that common denominator. We do not say that's 10x squared, it stays 5x squared. And then we want to check the numerator. Can we factor that? Can we simplify that any further? We can't, so this would be your final answer. All right, over here, we have, again, the same denominator. So we're going to simply subtract our numerators because there's a subtraction sign here. So it's going to be 9x squared minus 9x to the third minus x squared over x plus 1. Well, the numerator can be factored out. We have a GCF of x squared. This would be x squared, and then it's going to be 9x minus 1 over x plus 1. We can't cancel anything, so then that would stay our simplified answer. All right, so let's do some examples down here of that. We have 7 over 12x minus 2 over 12x, same denominator, so we can simply subtract the top and bottom. 7 minus 2 is 5 over 12x. Can we simplify that? Nope, 5 over 12 cannot be simplified, so this is your final answer. All right, over here, our denominators, again, are already the same. So it's going to be 2x squared plus 2 over x squared plus 1. Well, that numerator has a GCF of 2. And we don't need to put parentheses around it in the denominator. I just did that as a force of habit. So we can cancel off the x squared plus 1 on the top and bottom, and that will just leave us with 2. Okay, so then down here, denominators are the same. So 2 plus 1 is 3. So you have 3 over 3x squared. Well, the 3's on the top and bottom can cancel, but remember, if there's nothing on the top, it becomes a 1. So we have 1x squared. And then here, again, our denominators are the same. Now, when we subtract, we have to distribute the subtraction to both things. So what you could do is first do 4x minus 7 minus 3x, and then change that sign to minus 3. Just write it all out first. At some point, you'll be able to probably do that in your head. So we have 4x minus 3x. That's going to give us 1x. And then negative 7 minus 3 is negative 10. This will be x minus 2. Now remember, we can't cancel these x's because it's x minus 10 in this numerator and x minus 2 in the denominator because we are subtracting or adding in the numerators and denominators, we cannot cancel those. Up here, we could cancel the x squared plus 1 because we cancel that whole factor. We cancel the x squared plus 1 factor from the top and bottom. Here, we have the x minus 10 factor over the x minus 2. They're not the same, so we can't cancel that. So adding and subtracting when the denominators are the same, it's pretty simple, straightforward. We combine like terms, factor, and cancel if possible. You won't be able to factor every time, and you won't be able to cancel every time, even if you can factor, like we saw in the example up here. Now, on the next page, we're going to talk about adding and subtracting when the denominators are not the same. So now we're going to add and subtract rational expressions that have denominators that are not the same. So to kind of get an idea of what's going on, I have numbers here. So 1 over 6 plus 1 over 4, and we're going to add those. Now, you might say, well, I know I can multiply this by 4 over 4 and this one by 6 over 6. Multiply it by the denominator of the other fraction, and that will give me 4 over 24 plus 6 over 24. Whoops, 24, not 10. 24 equals 10 over 24, and then reduce that. Okay, we can divide the top and bottom by 2, so that's going to be 5 over 12. Now, you might have looked at that and said, well, I could have found the least common denominator, multiplied the first one by 2 over 2, and the second one by 3 over 3, and that would have given me 5 over 12, 2 over 12 plus 3 over 12, which is equal to 5 over 12. So we get the same answer either way. With these rational expressions, it's easier to do it this way and then simplify later. So now down here, to add or subtract rational expressions with unlike denominators, first we have to find a common denominator and rewrite each rational expression using that common denominator. Now remember, up here I had to multiply the top and bottom by 4 and the top and bottom by 6. Even over here I had to multiply the top and bottom by 2 and the top and bottom by 4. So when we go down here and add or subtract these rational expressions, we have to remember we're going to be multiplying the top and bottom. So here we have x over x plus 5 minus 2 over x minus 3. So what we have to think about is I want my denominators to be the same. The first one has an x plus 5 factor, and the second one has an x minus 3 factor. Well, if I need to multiply the first one by x minus 3 over x minus 3, and the second one by x plus 5 over x plus 5, because the first fraction was missing x minus 3 in the denominator, and the second fraction was missing x plus 5. So now we have to multiply x times x is x squared minus 3 times x, so 3x over x minus 3 times x plus 5. And then we have minus 2x plus 10 over x minus 3 times x plus 5. Now this looks like the problem on the previous page, where you can just combine like terms in the numerator. Remember, this subtraction goes to both things. So it's going to be x squared minus, well, there's no x squared, so it's going to be x squared. Then we have negative 3x minus 2x. That's negative 5 x, and we have no constant in the first fraction, but we have minus 10. So minus 10 all over x minus 3 times x plus 5. And then, as I've said before, we want to make sure we can simplify if possible. We want to factor the numerator if we can. So two numbers that multiply to negative 10 but add to negative 5, there aren't any. So this is your final answer. Let's look at example 2. So we have a bit more of a complicated one. We have 3x over x minus 1 times x plus 1 minus 5x over x minus 1 x plus 2. Well, they both have an x minus 1, which is great. The first one is missing x plus 2, and the second fraction is missing x plus 1. So we're going to multiply the first fraction by x plus 2 over x plus 2, and we're going to multiply the second one by x plus 1 over x plus 1. So again, we're multiplying the fraction, the numerator and denominator of the fraction, by whatever the denominator is missing. Okay, so then x times 3x is 3x squared. 2 times 3x is plus 6x, all over x plus 2 times x minus 1 times x plus 1, minus 5 times x is 5x squared. 5 times 1 is plus 5x, all over x minus 1 times x plus 2 times x plus 1. Now, luckily, again, we do not need to multiply out the denominator, so I'm going to keep it just like that. All right, so we have 3x squared minus 5x squared. That's going to be negative 2x squared. 6x minus 5x is plus x over x minus 1 times x plus 2 times x plus 1. Now, the denominator, you can write those factors in any order. If I'm looking back at this, I rewrote them in different order from here to there. That doesn't matter. You're just multiplying them. The order can be anything. Now, in the numerator, I can factor out a negative x. And I'm doing a negative x because my leading coefficient's negative. And that leaves me with 2x plus 1 over that common denominator, x minus 1 times x plus 2 times x plus 1. We can't cancel anything, so we leave our answer just like that. All right, these last two. Now they almost look exactly the same for these denominators, except this is an x plus 2 and this is an x minus 2. They both have x though. So we can multiply the first one by x minus 2 over x minus 2, and the second one by x plus 2 over x plus 2. All right, so then we'll go ahead and distribute. X times 3 is 3x. Negative 2 times 3 is negative 6. All over x times x plus 2 times x minus 2 plus 2x plus 4 over x times x minus 2 times x plus 2. Now, for the next problem, I'm probably going to do a little bit of a shortcut and not write out this step. What I'll do is I'll just write out the whole numerator over this common denominator, because now we're going to be adding our like terms here, 3x plus 2x is 5x, and negative 6 plus 4 is negative 2, all over that common denominator. It will just save us some time because these denominators can get a little intense, and writing that over and over again can be time consuming, so we can speed up that process a little bit. All right. This problem here, we have numbers now, 4 and 6. Well, we can multiply. All right, so this example here, okay, we have the x minus 2 that's missing and the x plus 3 is missing, which means we do need to multiply the other fractions by those, but we also have a 4 in the first fraction and a 6 in the second fraction. So instead of multiplying the first one by just x plus 3, I'm going to multiply it by 6 times x plus 3 and over 6 times x plus 3. And then the second one, I'm going to multiply by 4 times x minus 2 over 4 times x minus 2. So now we're going to do 6x plus 18 times 3x plus 4x minus 8 times 5 all over that common denominator. 6 times 4 is 24 times x minus 2 times x plus 3. So now we're going to distribute in the numerator. We have 6x times 3x, which is 18x squared, plus 54x, plus 4 times 5 is 20x, minus 40, all over 24 times x minus 2 times x plus 3. So now in the numerator we have 18x squared plus 54 plus 20 is 74x minus 40 all over 24 times x minus 2 times x plus 3. Now before I try to factor that numerator, I'm going to at least factor out a 2. I can factor out a 2 from everything. So 2 times then 9x squared plus 74 divided by 2 is 37x minus 40 divided by 2 is 20 all over 24 times x minus 2 times x plus 3. Now I'm going to check to see, can I factor that? That's a pretty nasty polynomial there. So let's see, if we're going to factor that, we can guess and check. And I said it before, try one of these down here as one of your factors. Whoops. So if I am guessing and checking, I have this 2 in front, and I need to multiply to 9x squared, but multiply it in negative 20 on the last 2. So I can do 9x and 3x, 3x and 3x, but notice what I have done here. I have x and x. So if this one's x, this one's got to be 9x. And then to multiply to get negative 20, I can't use 3. So I'm going to use minus 2, which means this would have to be positive 10. And then I'm going to guess, and I'm going to check this. Negative 2 times 9x is negative 18x. And then x times 10, nope, that's not going to work. So that is unfactorable. So I can at least now do 2 over 24. That will divide out to 1 over 12. So I have 9x squared plus 37x minus 20 all over 12 times x minus 2 times x plus 3. So just like our previous lesson when we were simplifying and then that turned into multiplying and then that turned into dividing and each of those skills stacked on each other, this works the same way. We started adding with like denominators and canceling when we could. Then we added when denominators were not the same. We had to make them the same, and then we could add them like we did on the previous page. All right, so again, that the factoring and the multiplying skills are going to be super important here, and just making sure you're going slow and being careful, not forgetting negative signs, doing basic arithmetic correctly. Like, I've seen people say, oh, negative 40 divided by 2, negative 10, just being a little bit careless. That would get you the completely wrong answer if you do something like that. So thanks for watching. Make sure to like the video and subscribe.